Here's a question, again from the review, talking about graphing. Taking an equation in general form that we've been given in question number 24, and saying, how do I graph it? Number one, what's my x-intercept? Number two, hang on a second, what's my y-intercept? Number three, what's my vertex and axis of symmetry? What is my reflection point to that y-intercept? And then finally, after we graph it, we can sketch it. Then we can find out whether it's, I guess, when it's increasing and decreasing, what the domain of range is. So in general, I'm taking a look at this, and I'm saying, let's see, a equals -2, b equals -8, c equals -6. And I'm just pulling the numbers out. A equals -2, b equals -8, c equals -6. Remember, the signs go along with the numbers. A equals -2 means, let's see, a is -2, less than 0. Less than 0 means it's negative. Negative means he's got a frowny face. He's going to be opening something like this. He's going to be a frowny face, and he's going to have a maximum value somewhere. So let's walk through what we've got for my x-intercepts. Let's find out where my x-intercepts happen. X-intercept happens when y equals 0. If y equals 0, then I'm going to kind of rewrite this and say 0 equals -2x squared minus 8x minus 6. And I'm going to solve that quadratic equation. Number one, I'm going to look to factor it, because that's always going to be my easiest way to solve that quadratic equation. If I'm looking to factor it, number one, I take a look at a greatest common factor, and I can divide out a -2 from each of my terms. And if I divide by -2, I get 0. 0 divided by -2 is 0. -2x squared divided by -2 is just x squared. -8x divided by -2, positive 4x. -6 divided by -2, my greatest common factor, -2, is positive 3. And now I factor the right side. 0 equals, because I got a quadratic equation, easiest way to do it would be to factor it. We could factor this as well, or we're given, but that's kind of messy with the -2 in front. And if we can factor out the -2, it makes our life easier. So I'm going to factor this as x, and we got to find, let's see, second sign's a sum. These signs are the same, so it adds up to positive 1. You could use the AC method, but boy, I tell you what, that'd be messy here. Second sign's a sum, these signs are the same. Add up to a positive number, there at positive, positive. Factor 3 to be 3 and 1. First, x squared plus 1x plus 3x is plus 4x plus 3. That's a correct factored form. I'm going to, again, find my x-intercepts by factoring this. Either x plus 3 equals 0 or x plus 1 equals 0. Subtract 3. Subtract 3. I got x equals -3, or x equals, over here, subtract 1. X equals -1. So my two intercepts are -3, 0, or -1, 0, because those are points. X-intercepts are points. So there's my two x-intercepts, -3, 1, 2, 3, 0, and -1, 1, 0. And there's my two x-intercepts. All right, y-intercepts, I'm going to go to blue. Y-intercepts happen when x equals 0. If x equals 0, that's really easy. F of 0, all we're doing is evaluating this at 0. Right up here, -2x squared, -2 times x squared, 0 squared, minus 8 times 0, minus 6. Again, these are zeros. See if I can make it a 0 without making it too messy. There's a 0. 0 squared, 0 times -2, 0. And -8 times 0 is 0. So a -6. F of 0 equals -6. My y-intercepts are x equals 0, y equals -6. At 0, I've got a -6, y-intercept 1, 2, 3, 4, 5, 6, y-intercept -6. And that makes sense, because we've got, again, we've got a frowny face, we've got a -2 as an A, so that means he's a negative guy. He's walking around with a frown on his face. The parabola is going to look probably something like that. So there is a couple of points that I'm looking at. What's my vertex? Vertex happens when, well, let's see. Vertex happens when x equals negative b over 2a. Vertex happens when x equals negative b over 2a, and that just happens also to be our axis of symmetry. So we can find when our x equals negative b over 2a, plug in negative b, negative 8 over 2 times a, negative 2. Negative 8 is positive 8, divided by negative 4 is x equals negative 2. X equals negative 2. So if x equals negative 2, well, that's part of my vertex. X equals negative 2, and all we have to do is evaluate the function for x equals negative 2. Now my y value, or my x value, is f of x equals negative 2, and I'm gonna, you know what, I'm gonna erase this. I'm gonna be more specific for this situation. I'm looking for my vertex. Vertex happens when x equals negative 2, so I'm going to look for f of negative 2 equals negative 2, and all I'm doing is copying this equation down. Negative 2 times negative 2 squared, because we're evaluating at x equals negative 2, minus 8 times negative 2, let's see, minus 6 equals negative 2 squared is 4 times negative 2, negative 8. Negative 8 times negative 2 is positive 16, minus 6. F of negative 2 equals negative 8 plus 16, negative 8, or sorry, positive 8, minus 6, positive 2. So that is my y component of my vertex. Negative 2, positive 2. So here's my vertex, negative 1, 2, positive 1, 2. There's my vertex right there, and sure enough, it sure is looking like a smiley, or sorry, a frowny face. Axis of symmetry actually is at this x equals negative 2. So we could probably find our axis of symmetry first and say that x equals negative 2 right here, if I can draw that correctly, accurately. There's my axis of symmetry right there, axis of symmetry. It's an A. Axis of symmetry is right there at x equals negative 2. The whole thing is symmetrical around that axis of symmetry. So there's my axis of symmetry. Now my reflection point is the last point that I can talk about. Reflection point, because my parabola is symmetrical with relation to that axis of symmetry at x equals negative b over 2a, x equals negative 2, then if there's a point over here, 2 spots, then there's also a point over here, 2 spots, and that right there would be my reflection point. Let's see, officially it would be negative 1, 2, 3, 4, negative 4, negative 6, negative 4, comma, negative 6. And that negative 6 comes from where my y-intercept was. It's 0, negative 6. It's also at the same distance from my axis of symmetry to the right and to the left. So this point here is the same y value, just to the other side of that axis of symmetry. Negative 4, negative 6 is my reflection point. So sure enough, there's my parabola. Looks like it goes through all these points. If I can make it come through all these points, I'll be happy. There's my parabola, somewhat. Again, a frowny face because a equals negative 2. He's a frowny face. From here, I can talk about my domain and range. Domain, any number can go in here. Any x value can go in here. This parabola goes on forever, down to the left and down to the right. Domain is all real numbers. Range is my y values. Y values, well, in fact, here's my max value. Max at y equals 1, 2, 2. There's my max value. So my range has to be y less than or equal to 2, because we could get up to that 2. The parabola includes that point. Increasing all the way from x equals negative infinity all the way up to this point here. All these points is where x is increasing. So x is increasing from, let's see, negative infinity, and probably should be x is greater than, not greater than or equal to. X is greater than negative infinity and less than our axis of symmetry, or the vertex point right there, so a negative 2. it's decreasing all the way over here. Decreasing value is going over here. So x greater than -2 would be where the parabola is decreasing. And there's a graph from a general form of a parabola.